For centuries, humanity has gazed up at the infinite tapestry of the night sky, a fundamental question echoing through the ages: are we alone? Is this tiny blue marble, teeming with life, merely a cosmic anomaly in a vast, silent universe? This ancient yearning for answers has driven us to build ever more ambitious eyes on the cosmos. And now, one such eye, the magnificent James Webb Space Telescope, may have just provided our first genuine hint, a whisper from the void that could reshape our understanding of existence itself. What if that whisper came from a world 120 light-years away, a world unlike any we've ever truly imagined? Our story takes us to the constellation Leo, a distance so vast it's almost incomprehensible. There, orbiting a dim red dwarf star known as K2-18, lies an exoplanet that has captured the imagination of scientists worldwide, K2-18b. This isn't just another distant rock, it's a super-Earth, roughly 8.6 times the mass of our home planet, and residing squarely within its star's habitable zone. For years we suspected it might harbor liquid water, a cornerstone for life as we know it. But the recent data from Webb has revealed something far more profound than just the potential for water. What could this distant world possibly be hiding in its atmosphere that has scientists buzzing with a mix of excitement and disbelief? The genius of the James Webb Space Telescope lies in its ability to peer through the atmospheres of distant worlds. As K2-18b passes in front of its star, Webb captures the starlight filtered through the planet's atmosphere. Each chemical element and molecule leaves a unique fingerprint in that light. And what Webb's highly sensitive instruments detected on K2-18b sent shockwaves through the astronomical community. Unmistakable traces of methane and carbon dioxide permeated its atmosphere. These are common molecules, yes, but their presence together on a world in the habitable zone is highly significant. It hints at an active, complex atmospheric chemistry. But these weren't the only, or even the most astonishing molecules Webb possibly detected. One particular trace could change everything. And then came the whisper that grew into a roar of scientific curiosity, the possible detection of dimethyl sulfide, or DMS. On Earth, DMS is almost exclusively produced by biological processes. Think of the smell of the ocean. That distinctive scent is largely due to DMS released by phytoplankton, microscopic marine life. Finding this molecule in the atmosphere of an exoplanet in the habitable zone is, to put it mildly, extraordinary. It's a tantalizing clue, a chemical signature that, on our planet, is synonymous with life itself. Could this tiny biological fingerprint be the very first real evidence of alien life? Or are we leaping to conclusions too quickly? While the excitement is palpable, scientists urge caution. The detection of DMS is currently tentative, requiring further confirmation. Even if confirmed, it doesn't definitively prove life. There's always the possibility of unknown non-biological, geological, or chemical processes that could produce DMS under alien conditions. However, the unique combination of methane, carbon dioxide, the absence of ammonia, which would suggest a hydrogen-rich but non-oceanic world, and the potential for DMS paints a compelling picture. It aligns perfectly with the theoretical model of a Hycean world. What exactly is a Hycean world? And why does this particular classification make K2-18b so tantalizing for the search for life? A Hycean world is a fascinating concept. A planet much larger than Earth, enveloped in a deep, hydrogen-rich atmosphere. But beneath that dense shroud lies a vast liquid water ocean. Imagine an ocean planet, but instead of an Earth-like atmosphere, it has one more akin to a mini Neptune, yet still warm enough for water. K2-18b fits this description perfectly. Its hydrogen atmosphere would be incredibly thick, potentially exerting immense pressure, and the deeper layers of the ocean could be incredibly hot. This isn't a paradise beach world. It's a world of extreme conditions, where life would have to be incredibly resilient and adapted to thrive in a crushing, alien environment. Could life truly emerge and flourish in such an extreme, high-pressure, hydrogen-rich ocean, far beneath an alien sky? On Earth, life has shown an astonishing ability to adapt to the most extreme environments, from creatures thriving in boiling hot hydrothermal vents at the bottom of our oceans, powered by chemical energy rather than sunlight, to microbes living deep within rock. The rules of life are far more flexible than we once thought. Scientists theorize that if life exists on a Hycean world like K2-18b, it would likely be microbial, adapted to high pressure and potentially utilizing chemosynthesis, drawing energy from chemical reactions rather than photosynthesis. The thick hydrogen atmosphere would block out much of the star's light, making surface-based photosynthesis unlikely. So what are the next steps in unraveling the mystery of K2-18b? And how much closer are we to a definitive answer? The journey to confirm or refute the presence of life on K2-18b is just beginning. The next crucial step involves further observations with the James Webb Space Telescope, using different instruments and longer observation times to absolutely confirm the DMS signal and other atmospheric components. Scientists will also be developing more sophisticated atmospheric models to rule out any non-biological explanations for the observed chemistry. We're talking about meticulous, painstaking scientific work, peer review, and independent verification. This isn't a sprint, it's a marathon for the ages. But what if these findings are confirmed? What would it truly mean for humanity? For our place in the cosmos? Imagine the implications. If K2-18b genuinely harbors life, even microbial, it would be a paradigm shift unlike any other in human history. It would suggest that life is not a unique phenomenon to Earth, but perhaps a common occurrence across the universe. It would change our philosophies, our religions, our very understanding of what it means to be alive. It would ignite a new era of exploration and scientific inquiry, driving us to search even harder for other habitable worlds, and, perhaps, more complex forms of intelligence. The question of "are we alone?" would finally have a profound, if complex, answer. But beyond K2-18b, what other cosmic wonders might the James Webb Space Telescope and future missions reveal in the vast, unexplored universe? K2-18b is more than just an exoplanet. It's a beacon of possibility, a testament to humanity's insatiable curiosity. It's a reminder that we live in a universe far more mysterious and potentially far more populated than we've ever dared to dream. The James Webb Space Telescope has opened a new window onto the cosmos, and K2-18b is just the first glimpse of what lies beyond. The search for life continues, fueled by hope, rigorous science, and the enduring wonder of the night sky. The universe is vast, and the story of life, both here and perhaps elsewhere, is still being written, and we are all privileged to be living through this incredible chapter.